Well, it's recording, yeah.
Okay, thanks. So, welcome everybody to this extremely well attended talk. It does say get into 4 groups, but I think probably 2 groups will suffice, so we've got 3 and 3, that's fine. Can you please go to this web address, pf.com/survey, because we'll do one at the end as well and see if anyone changes their mind.
So we've got the siloed.
Let's put our hands up and just say what do you think you are as a person. So not your job title, but internally you. What do you know, from what you think architecture and engineering is, what do you think you are? So during this, we're going to be presenting some thoughts on what the difference between architecture and engineering is, but it's very much a what do you think architecture and engineering is. So I'll give you some steers of what pragmatic thinks enterprise architecture and engineering is. You don't have to agree with them. It's just there to kind of set some context. Just so you know who I am, I'm Kevin Smith. I wrote my first program in 1978, so I've been in the industry about 40 years now. The last 15 or so has been in enterprise architecture, and 2008, so just coming up to 10 years, the Pragmatic Enterprise Architecture Framework was launched, which is the 20% of the fundamentals you need to get right to get 80% of the benefit. So what we'll be doing is I'll give you a brief introduction and give you some ideas of what we think the difference between architecture and engineering is. Then let you have a bit of a workshop for 10 minutes or so. After that, I'm going to give you a bit more pragmatic thinking of what we think the differences are between architecture and engineering. Then we're going to have a lot more time to have a workshop for you to discuss jointly together, in your groups rather. And then we'll get one person from each group to present what that group has decided the differences are. And then at the end I'll give some final comments. When you're thinking about what is enterprise architecture and what is architecture and what is engineering, I think it's helpful to not just think of one and think, right, what can I write down about architecture or what can I write down about engineering? Try to think of contrast. So what does an architect do versus an engineer? How does an architect think versus an engineer? So if you can write in pairs, I think that would be helpful. So from pragmatic's point of view, which is basically my point of view, over 40 years of experience, which could be wrong, architecture and engineering I see as kind of 2 sides of the same coin. You can't really have one without the other. They both benefit each other, but they're both fundamentally different, but kind of they're very interrelated. What we tend to think, from a pragmatic point of view, is we architect the whole. So architecture is about the broad things, and then engineering is about engineering parts of that architecture, which might take a long time to do. So this is one of the problems when we talk about architecting with business leaders who don't understand architecture, is that they think, oh, because you're architecting the whole architecture of the enterprise, that means we're changing the entire enterprise. We don't have money and time to do that. Well, of course, it's not. What we're doing is architecting the enterprise, but we're going to engineer it tactically over time. So architecture is kind of horizontal, engineering is kind of vertical. Just from my point of view, I think my brain is an architect's brain and an engineer's brain. I think earlier on I was more an engineer, and as I grew older I became more an architectural kind of thinker. So here's some kind of guide. So we think architecture is more about asking the why question. Why are we doing this? Oh, we're doing it because of that reason. Well, why? Why is that the reason? It's about understanding things, asking questions and thinking about things, versus engineering, we think, is more about the how, the doing things, the creating solutions, talking and doing things. And one of the lines is that architecture finishes when there's nothing more to take away, and engineering finishes when there's nothing more to add. So actually, if you think about building architecture is actually not the physical building. It's the patterns that was used to create the building. That's part of the architecture. But the architecture of a building is the spaces, actually. It's not the physical, it's the interfaces that have been created. So it's about taking things away. Imagine starting with a solid object and taking things away to create volume of spaces. Whereas engineering is about building walls and things like that. So, over to you. Do you have any questions, first of all, on what I've what my thoughts about the difference between architects and engineering is? Right. So, we don't actually have a whiteboard. So, can you get into your groups and start having a bit of a chat? Not for a huge amount of time, maybe 10 minutes. Maybe go around each of your tables and each person explains to the other person what maybe they think the difference between architecture and engineering is. Then we'll get back together and I'll give you some more pragmatic thinking.
When we've worked out the difference, what will we achieve?
Understanding, which you could say
Yes,
architecture.
I'm just trying to understand what the outcome will be when we've finished working out what the difference is.
The outcome will be that we will know what the difference is. I think in many why is that important?
Yes.
That's a very good question, which I should have covered. I didn't cover. The reason this is important, I think, is because they are literally fundamentally different things, very closely related, but fundamentally different things, requiring different ways of thinking, different ways of working, and looking at different things in different ways. In most organisations, from what I've seen through my professional life, is there's great confusion between the job of an architect and the job of an engineer. So what's happening is companies are employing engineers and calling them architects and asking them to do architectural things, when in fact they're not architects. They don't think like an architect, they think like an engineer, and therefore they do engineering designs rather than architectural designs. So this question, I believe, is utterly fundamental to allowing the transformation domain in companies to work correctly. Can you imagine what was happening in the building industry if we had engineers who were called architects? So you had engineers doing architectural drawings, and you imagine what would happen if you had architects doing engineering drawings. It would just be a complete and utter mess. But that generally, I think, is what happens in most enterprises. It's just a mess. People are doing things.
I disagree. I mean, our engineers is a well-defined. We're an asset-heavy industry. Our engineers build physical assets and control performance characteristics of them. The architects are more business IT-led. I don't see the same confusion actually. Just personally, in my
every time, what I'm always talking about are the problems in the enterprise transformation domain. That's why we need frameworks, that's why we need best practice and all the rest of it. Those companies that are wonderful companies, who absolutely, completely understand the difference between architecture and engineering, then there's no point in them thinking about the difference because they already know the difference and everything is, there is no problems. So I'm sure there are examples where companies and people working in a company know the difference between architecture and engineering. In my experience, I've not really seen that.
It's the context of this software architectures and enterprise architectures, not real architecture, building architectures. The word architecture engineering for a building is different from software engineering.
Is it?
And software architecture, for example.
Is it? At the fundamental level, is it different?
sorry, I'm not trying to figure out. I'm just going to try the next session. It's more data architecture.
That's another good question. So when we talk about engineering,
I think they deal with different subjects. So in that regard, there might be conceptual overlaps and similarities, but the subject is different. So
correct.
You know,
So I'm asking
when
you.
it's in the opera house, it's easy to see the architecture, whereas so you can begin to understand the difference between the architect and the engineer's contribution to that project. Because the engineer had to work out how to fulfill the architect's concept.
So what we're talking about here is, I want to be domain unspecific.
Right.
think about the problem in whatever domain you want to think about it as. But when you write something down, this is how I would describe our architecture, and this I would describe engineering. Let's say you're thinking about software architecture, application architecture. Once you've written that down, say to yourself, would that also apply to buildings? Would it apply to aircraft? Would it apply to enterprises? Because if it doesn't, then you're looking at a domain-specific difference, not a difference between architecture and engineering. So I want to get the domains out of it. Fundamentally, I want organisations to understand, or management to understand the difference between architecture and engineering. Don't want to talk to them about enterprise architecture, or data architecture, or software engineering, or any of those things. This fundamental difference, where architecture, we say, is a way of thinking about something that's complex and volatile, because you just can't think, you have to think it that way.
Like the gentleman's just saying, in certain businesses that's really obvious, and in certain other businesses it's really not very obvious. And it depends on the domain that you're in. In some domains it's very obvious, and in other domains it's not. Like if you're building a road, it's very tangible.
Well, yeah, I've never been very happy with this attempting to map building architecture against IT architecture. It doesn't.
That's why
that is not a good analogy as far as I'm concerned.
Right.
If you go back to some of the early papers on McKinsey, what they talked about was town planning and planning Paris and so on, with the Haussmann boulevards and things. And that, I think, is a better analogy for enterprise architecture, where you're creating a broad suite, a pattern of rules and so on that will be obeyed into the future. And the average architect, I don't think, does that. The average building architect.
Okay, once again, think about whatever domain you want to think about. Whatever domain you're happy. If you're happy thinking about data architecture, and think to yourself, what's the difference between data architecture and data engineering? Then think in terms of data.
And I suppose one of the things in context, because when you look at architecture and what is an architect, is the Chartered Institute for Architecture, that they clearly define how that term can be used. And they recognise within the IT industry that terms such as enterprise architect exist, and that there's different domain architectures. So from that sort of perspective, I think just architecture and engineering, the context would help, because recognising the typical domains that you see across business, enterprise, information, technology and stuff like that, I think it's more of a context thing, but I can definitely see the difference between the depth and the breadth across both, because if you use the house analogy, is that if you've got an engineer that's fantastic at making stairs, how do you know that they're good at levelling off with the floor and it's going to get the right amount of light and space coming in through windows, sort of thing. And I also see that within the broader sort of EA space, if we're looking at what is enterprise architecture, when you start to look at capabilities, processes, and actually understanding what those business needs are and mapping them through to something from a technology perspective, that has the right information flow to get it to the right people at the right time in the right place.
Yeah.
So for me, I'm slightly uncomfortable with the context.
What context would you like?
I suppose a more
you want to think in terms of enterprise architecture?
I think
in terms of enterprise architecture. Like I say, you decide on what domain you want to think. What context do you want? Do you want to think in terms of building architecture? Do you want to think in terms of enterprise architecture, data architecture, software architecture? I don't mind. What we're trying to get at is the fundamentals of architecture. And hopefully, when we define the fundamentals of architecture in software, that will inform us of what the fundamentals of architecture are in data architecture. And what we understand the fundamentals of the difference between data architecture and data engineering, that will inform us to understand enterprise architecture and enterprise engineering.
Sure. So I think really then from...
Do you think there's a right answer to this?
Sorry?
Do you think that there's a right answer to this?
I think...
We'll come across through this process.
I think there are fundamental differences, and there must be some way of expressing those fundamental differences between architecture and engineering. And if you decide...
No, I agree with that.
If people decide that architecture and engineering, like Zachman, thinks architecture and engineering is basically the same thing, because he uses the words interchangeably, you said in the
Yeah.
course I attended. I think that's really bad because we have engineers doing the job of architects in companies, and we have architects doing the jobs of engineers, and that's just bad. No one benefits, especially the people doing those jobs.
I think within the IT.
Just to add, actually, because of this very problem, I've actually, for my sins wearing my academic hat, my practitioner hat, is actually done some work into relating enterprise architecture, enterprise modelling. So we've tried to come up with a common framework to at least understand the similarities and the difference between them. And where, for instance, an engineer might use the term decomposition and composition, an architect might think in terms of conceptual architecture, physical, logical architecture, or design. But what we try to do is identify basically what the similarities are and the differences are, and where you can achieve a common understanding. Because certainly my experience has been that you can have endless discussions about the subject and get absolutely nowhere with it. And I think the trick is to find what's the shared meaning between an engineer's perspective and an architect's perspective. And then you say, I might, for instance, if I'm thinking software engineering, I might think object orientation, I might think types and subtypes. If I'm an engineer, I might think composition and decompositions. I've got for instance, a car consists of wheels and steering wheels and doors and all the rest of it. The difference between how an engineer breaks something down and how an architect breaks something down, you can instantly see that stop disagreeing one another, because, for instance, you'll get, well, you're not applying Viscov substitution principle, means you have types and subtypes, and an engineer would say, well, that's not my point. It's about taking a unit of interest and what's its constituent parts and decomposition. Breaking it down into its, and then what you do is you decompose and then recompose. And then you start to get a common understanding.
So maybe one of the differences between architects and engineers is that engineers decompose things into smaller and smaller pieces, but architects compose things into bigger and bigger things. Maybe that's one of the differences you could write down.
Yeah.
Can I ask you one question? Put your hand up if you think understanding the difference between engineering and architecture is important.
For a business.
For a business, and for people working in a business.
Absolutely.
So, you don't. Would you like to understand why? I don't want to put you on the spot, but I really would like to understand.
I wasn't sure whether I should put my hand up or not. My thinking has gone on a slightly different track, which is that the classic problem with this term enterprise architecture, and
I'm not talking about enterprise architecture,
and also with models like TOGAF, is that we focus on that we're in a computing context, and enterprise architecture is not software architecture. And most people who are enterprise architects probably come up through the IT background, whereas arguably they should be organizational design people from HR or from process or something else. So that both these terms, architecture and engineering, here are extremely fluffy. And
exactly.
I think potentially you have to break them down before you can do your comparison. Because I think just to say, there are things we can say about all architecture that are different from things we say about all engineering. I suspect we'll end up with
Are you an architect?
an empty set.
Are you an architect?
Yeah.
Okay, so how many people here are architects? Right. Well, as architects, I think you understand the difference between talking about something and abstracting that something to another level, and the power that you get by abstracting that thing to another level, a higher level.
But
Okay.
most of the time,
Wait.
most of the time I'm a solution architect, which I would say is engineering.
So, as architects, I would expect you to understand why I don't want to talk about enterprise architecture, which is at this level. I want to talk about architecture. Let's understand the fundamentals of architecture. If it helps you to think about the fundamentals of architecture by thinking in different domains like IT, enterprise, solution, whatever, then fine. But it's powerful if we can If we can define the difference between architecture and engineering, then we have defined the difference between solution architecture, solution engineering, enterprise architecture, enterprise engineering, application architecture, application engineering, data architecture, data engineering. So as architects, that's what you do. So I'm kind of asking you to be a bit architectural in your thinking.
I think that the thing is, what we're doing is discussing, we're having a sort of category discussion, which is a very academic sort of or abstract kind of thing. And then we're trying to relate it to the real world, where we know that the job is something like to take an aspiration, a vision of the business, and take it all the way down to something that works. It's a solution that's actually operational and works. And that journey from vision to something that works doesn't just go architecture, engineering. It goes conceptual, logical, physical, design, build, deliver, change, manage the change, get it working, realise the benefits, then go round the loop again. And that's got lots of activities, many, perhaps 20 or 30 different types of activities, 20 or 30 different types of skills, of which architecture is a bit, engineering is a bit, but there's other ones as well.
That's the trick, actually, because the thing is that you're coming in from those different disciplines, but what you want to create, how can I put it to work? From the conceptual, from an engineering knowledge, how can you bring engineering knowledge to bear on it, architectural knowledge to bear into it, and then how can you create a method or a framework that can actually apply it to real projects, and finding what the common basis of those terms are. You can, I'd say successfully, advisedly, but you can, to a good extent, start to get the benefits of both without getting into sort of ethereal discussions about what is where, with practical examples that demonstrate how it can work. So I'm sorry, I'm probably stealing a bit of thunder from my session this afternoon, but the plan is that we start to bring them together, we put them in an actual project, we see what the similarities and differences, because I'm from an enterprise architecture background, but I work with a guy who's a systems engineering background. And what we've done is to try and find what the differences are and say, right, let's have, in this project, how do we realise it? How can you, for instance, apply the principles of composition and decomposition in this conceptual, contextual sense as well? And that's, when you start to see it working, that's when you really start to see the benefit of bringing in architecture. And I don't mean to sort of say it's just my own personal experiences of working with this very problem.
The problem we're experiencing here is this question is a very difficult question. I think I've got an answer to it later on, which I'll show you, but I don't want to show you my answer and then you just go, oh yeah. I want you to think about it. And the fact that you're finding it difficult, I think you're finding it difficult, that's the point.
I think with this question is that I think there's very good points of view from different angles around this, and it's those words all up there really mean and relate to the audience in different ways. If you were to have building engineers and building architects, they would have a different view to people that have a business and IT background, because IT being a younger...
You're thinking at the domain level. Physically, doing building architecture and doing software architecture are completely different, okay? But the discipline of architecture that both are using is the same.
Agreed.
It's architecture.
Absolutely agreed. And I think with IT being such a young industry and how we've seen things evolve from mainframes and things over the years, and how we've seen architecture or the role architect mature and develop, an observation that I've seen across many industries now is that depending on the size and complexity of the organisation, architecture serves a different value to those organisations, depending on what it is they're actually trying to do. From a purist perspective, in a more mature organisation, the architecture being able to create that fluid continuum from an idea or vision all the way down something that continues, that is very different to the engineering that you would see in that sort of organisation versus say, a start-up company, which all that they're caring about is being able to develop engineered code because they're trying to spin up microservices as fast as possible.
Okay. So what I would say to that is, a difference between architecture and engineering is when you are when you are not volatile and not complex, which is a startup, they're not volatile, they're not changing rapidly, and they're not complex because nothing exists.
Yeah.
You don't need architecture, because architecture helps you deal with complexity and the volatility of change of something.
I agree.
So that's another difference you could write down.
Yeah, I think one of the key attributes of the architect is to understand how the thing you're designing has to accommodate change in its environment as it's going forward. Whereas the engineer is going to design the solution to that, but doesn't have to think of what the areas of resilience need to be. So does it need to stand up to strong winds? It's an architectural question. The engineering is how will I design it so that it will stand up to certain strong winds that the architect has specified. So it's change. And so an engineer is typically interested in efficiency and effectiveness, whereas the architectural additional, they're also interested in efficiency and effectiveness. The additional architectural dimension is time, change.
I'm going to step out of this conversation just for 5 minutes because I want you all to discuss, because I don't want this to be you challenging me and me telling you. I'm going to give you my views in a little while. I want you to discuss and argue against each other.
Are we in one group or are we in two?
I think you can be in one group now, to be honest.
Can we all move to one table then?
Any chance I can stay?
Yes, I'll let
There's some outside, isn't there? If there's some outside, I left mine on the train.
There's a whole box of pens.
Is there a whole box of pens outside?
I'll go bring one to you.
You're going to get a whiteboard as well. For some reason.
I think there's a...
Oh, we're going to have one now.
Yeah,
Let's start thing going.
Oh, is that brandy one?
I'll go scratch
I don't know, I came from an engineering background.
Right.
Only last year I went into the enterprise architecture team.
Sorry. Can we introduce something?
Yes, I know.
Sure. You start, because
You want to companies as well? Okay. So Paul Stevens, I'm enterprise architect, and I say that because I don't cover all the four disciplines in terms of the I look purely at infrastructure and technology because that's a huge topic for us. And
who's us?
Uniper. So they're a power generation company. They were spin off from Uniper. Juniper about today.
No. That's
And we split away from E.ON about 2 years ago. So it's all the dirty bits. Coal.
You've got all the dirty bits.
Yeah. The job I was given was basically how do you take a very complex infrastructure servicing 75,000 users. It's very hard to break it up and create effectively 2 new ones. One comes to the
Yeah.
So the more of the town planner, that's the job I do. I have to look at from a town planner's perspective what we need to have to actually achieve separate infrastructure from the original company. I'll give you the points I always think about in this kind of job is that the architect side of it has to look at the what we need to do and why we do it. About the money aspect. The how.
The instructions and then come back to the answer.
That's a very good question. The how is the engineering. How we do it together.
Okay,
So,
We're going to get to that. We can't do introduction.
Yeah. Finish it 20 minutes.
Well, we've got 40 minutes, so I'll skip the introductions and just get into the discussion.
Just very briefly, yes.
John Estelle, contract architect, mainly solution, sometimes enterprise, telco space.
Simon Jewell, and I work for Scottish Widows as an enterprise architect, Gemini, Circuit Consulting, Avanade, and now I'm contracting. I'm really enjoying it. Just finished a contract with BT, so particularly interested in the top part of architecture, where you're translating from the business aspiration to the architectural capabilities required before you go into the design and the solution. That's an interesting question to me.
Simon Polovina. I work both as an academic and a practitioner. I come from a sort of SAP enterprise architecture background, but I'm also interested in what I call conceptual architecture, understanding, this uses technical terms, the ontology, which touches on this subject. So I work both as an academic and a practitioner.
Okay, Chris Banks, I'm an enterprise architect with a domain focus in technology around digital workplace for a global insurance company. Over the past 10 years or so, I've worked in EA, SA roles across public, private sector, and industries, also doing some stuff in government. Prior to that, about 10 years in service operations management, started in systems engineering.
Right, let's go.
I think that for me, the architect in this kind of context is looking across multiple systems, and that's kind of it may not be 100% accurate, but the architect is looking across multiple systems, and one of their jobs is to maximise the value of the investment that you've already got in your estate and to maintain it going forward and so on and so on. Whereas engineering, very often in a simple sense, we tend to think about that as building one system or making changes to one system and maybe to a few other neighbouring systems, but it's a much more focused on the end result.
I suppose from my perspective at times, and what am I thinking? I think an architecture thinks in terms of layers or types. Bigger objects broken down into little objects and subtypes. So, whereas an engineer looks at the idea of breaking things down into its constituent parts. So there's a term that I borrow from object orientation, which I think that architecture thinks in terms of isers. Yeah? So a manager is an employee, that sort of thing. Whereas an engineer thinks in terms of I'm an employee. What sort of things do I do? What's my role, name, and that sort of thing. And I think that's been, in my experience, one of the difficulties. It's because, for me anyway, it's because the discipline, I think, of engineering and architecture is you're wired to think in slightly different ways. And I think that's one of the biggest challenges that I've had.
I think those layers and types, one of the things I've been looking at is capability modelling approach to architecture. And I think there's sort of three bits or three domains that you think about as an architect. There's what capabilities the business needs in order to achieve what it wants to achieve. There's what are the services or capabilities logical that are needed to facilitate that. And then the engineering bit is how you design that. And to give you an example, in the building, when you're building, I've just been doing an extension on my house. So the first bit is the fact that I want to go to the wall and press the switch and the light comes on, and press this switch and the blinds close. The architecture of that is I need power, and I need water, and I need drainage, and I need rainwater, and I need a 5-amp circuit, and I need a 13-amp circuit. So I've got all these networks which are going to go out and connect everything together, which underpin the fact that I can go to the wall and press the switch. And my experience is that that's the architecture. If you don't get that bit right, then when you come to engineer it, you engineer it in the wrong sequence, put down the paving slabs before you put your rainwater network in. And then you're relying on the engineer to engineer those components that you built. So, the guy who has to engineer the actual frame of the building You know, he has a whole range of skills and capabilities that I don't need to have as the architect, because I'm offloading all of that to that engineer.
So I did a similar thing. So I had an extension down the wine course. We got into software here. So I looked in terms of, I wanted the extension to look like it was part of the original house. So the brick, the space itself, because it was just a single story, I wanted to have the roof for it as part of the roof, because it's quite narrow in space. I wanted to have, so that when you walked in, you automatically looked up. You didn't look at how narrow the room was, you actually looked at how big it is, how big it was in width. And then start with, obviously, power and monitor and other utilities into the room. But then that's the limit of the skill I had. And then I had to call a real building architect to say, is it possible to do that in the space I've got?
You see, I think what you were talking about in terms of electrical is not architecture, it's engineering.
No, it's definitely.
Well,
It's definitely.
let me explain what I know. What you think. Let me explain why I think that.
The reason why it's architectural is that the architect has to consider the networks and what's connected to all the networks.
Okay, so let me explain.
Hold on. The engineer knows how to build the networks and knows how to connect to them. So I employed electricians to create the network, but I was the one who said there's going to be a switch here and there's going to be something that happens out there. When I press the switch, that happens. The engineer is the one who connects the network to the main, and they do all the engineering of that. But the architecture is that there has to be power.
So maybe we're talking at cross purposes?
Yeah, I think we are.
Because I'm building a house, so I designed the house, and I work with an architect to architect the house, and I work with the engineers that engineered the house. So I know a little bit about the subject like you, gone through the same process. But while I was going through that process, because I'm always thinking about what's the difference between architecture and engineering, I was very interested to go through that process with my mind going, is this architecture? Now are we doing engineering now? And it was very clear that the why, or what was required, so for example, like you said, a switch here and a switch there, and I want both switches to turn that light on and off, for example, or I want one switch here that turns that light on and one switch there that turns that light on. That is part of the architectural requirements, but the solving of that problem, that's what the electrical engineer does.
Yeah, but I think
let me finish. So there was architectural drawings which did not include electrical. They included electrical requirements, like a plug here, a switch here, and a light there. Then those drawings go to an electrical engineer, a plumbing engineer, structural engineer, who then do the structural engineering, electrical engineering, plumbing engineering. So I saw that, you know, one of the things I say is architecture is much more about the why. Exactly what you said. Why are we doing this and what do we want? And engineering is how do we do that? Well, we need to
you're telling me the answer,
the same.
But what I'm suggesting is that you're thinking in twos, I'm thinking in threes. So you've got the first bit, which is what you talked about. I want to press the switch and that comes on. The second bit is what are the capabilities required to make that happen? And the capability is an electrical network that connects all the electrical bits. And there's another capability, because that switch I also want to connect to a pump that's connected.
Who designs the electrical
capability?
Who does that?
Hold on a second. So then the pump is then connected to the water, which is another network. And then the water is connected to the sewage, which is a third network. So I've now got three networks which I need to put in place, each of which requires a completely different engineering skill set, but which need to interoperate to generate something which is bigger than the parts that they've created.
So what did the architect do?
So that's the middle bit, and then the third bit is the engineering. So I think it goes architecture, and the architecture has these two pieces. One is, if you like, the use cases, how the building is going to work to the end user. The second part is what are the capabilities, the logical capabilities that need to be built in order to deliver that use case experience. And then the third bit is that bit.
So we're agreeing on this, basically.
I'm saying there's three. There's a conceptual, logical, and engineering.
Okay.
Piece.
We're not talking about.
And the architecture brings those first two together.
Okay, but we don't have three roles. We don't have architects, engineers, and some other random role in the middle that no one knows the name of, do we?
Yeah.
We're trying to get to the core of what's the difference between architecture and engineering. There are various
we get lots of confusion in businesses because we only think in these two. We don't think in three.
In fact,
that's the source of the confusion that we're trying to address.
Okay, you're saying I'm thinking in two, but you're correct because you're thinking in three. Actually, my framework's thinking six. There's not 3 levels. There's actually 6 levels. So it's not how many levels, because architecture and engineering is performed at different times. You don't do application architecture when you do enterprise architecture. That's later on, right? But just because it's later on, we don't call it engineering. We still call it application architecture.
And I think one of the key things is that ultimately, when you're taking the current state to the target state, an architect's going to look at the whole, and also within whatever frameworks or methods that are applied, generally looks at the level of maturity and what the starting position is, because you can't go from typically, say, A to Z. You've got to do the alphabet in the middle to be able to get there, and there's certain things you get to develop a roadmap for.
We need to move on.
I think what happens is that the architect has to integrate the logical capabilities so that they deliver the outcomes that the end user, who's me in this case, wants. And then the engineers can come in as specialists in each of those logical capability areas and build it such that that particular domain works. So engineers are nearly always domain specific. Architects integrate the engineering domain
does architecture
in order to deliver the outcome that the user wants. And so I think you've got this.
Can we say architects are generalists and engineers are specialists?
Because it's like it seems to me that architects are setting the context or the sort of by which engineers can perform in, because this is kind of the what and why I want it, and how do I go about it? How do we make it so? I think that's what you turn to engineering capabilities.
It's your point about decomposition. You're decomposing,
yes,
but it decomposes fractal-like. So every decomposition, because it's a system, you're decomposing one system into a set of system components that themselves are systems, which decompose into sets of systems which themselves are systems. So everybody, you need a specialist in every systems area, but every systems area will have within it systems.
You've got systems, you've got subsystems, and you've also got interrelationships between systems, because those systems, as you said, have got to interact with each other. So you define the systems, then inside the system, but they've got to interoperate, because it's all to achieve one thing, isn't it, overall?
I disagree with that in the sense that with architects, you can have some architects that are domain specialists that are a bit of a blockhead and can go down right into the details still. But because of the experience, they're generalists and they're able to step back and look at the.
But isn't that because they're wearing 2 hats? They can put an engineer's hat on. It's not the architect's job.
Experience, competence, attitudes and behaviours. It's a combination of all of those things. But one of the things generally from defining the what and the why, what you'll generally find is architects live in more of a change world of transformation, and maybe defining what guiding principles are for how the state should exist when it's arrived at, or how it goes through, because an engineer could live in a change and a run world where the paths might not necessarily cross as much with an architect in the run world, because the how for the engineer is it's broke, fix it.
What could we put over here? If architects are kind of looking at guiding principles, what might we put in the same category of enabling principles? Standards operating procedures. So let me go through some differences that we've defined, because if everyone can get a very clear idea of the difference between architecture and engineering, I think companies will work a lot better together, people in them. Because the word architect tends to be used as a moniker for people who need to be paid more money or who need a job promotion. First you're a solution engineer, and then the next day you're an enterprise architect. How did that happen? So what we're looking at here are different categories. See what we're talking about here. Different categories, and we are not saying that zoom in a bit. We are not saying that architecture, there's no hard line between these things, yeah? We're saying architecture is more about that, and engineering is more about that. It doesn't mean exclusive, it means there's a grey area, which is why we fade from blue to green here. So, let me just run through these. This is what I think. Afterwards you can discuss. So I think architecture is more about art than science. It doesn't mean it's not science, it means it's more about art than science, whereas engineering is more about science than art. Because engineering is based on the science of load bearing and all of the rest of that stuff. Architecture tends to be more about looking at the why, engineering more about the how. You said why and what, I agree with that. Architecture tends to be thinking more about outside in, that is thinking about the context of a system and what the context is driving the system to do, whereas an engineer tends to be more about, I've got to design this system and it has to work with that stuff out there. Architecture tends to focus on the whole, whereas engineering tends to focus on the parts, which I think we've covered. In translation, we're going from the why to the what, or the what to the why, depends on how you use the words, whereas engineering is going more from the what to the how. So you can see maybe the what is in the middle, so we go from why to what to how. Maybe this is in the area of that third middle thing that you're thinking about. Architecture tends to deal in uncertainty. Engineering deals in certainty. Engineering does not say, will this floor support the wall? No, it definitely will support the wall, if we are certain. For architecture, an architect's impossible as an opportunity. Anything that's impossible is, right, let me explore that. For an engineering, that's a constraint. It's impossible, that's a constraint. In terms of function, I'll talk about these two terms, abstraction and elaboration. So there are at least 3, if not 4, ways of abstracting and elaborating. So the simplest is by omission. So if we have some information going from high level to low level, by omitting information, we are abstracting. By adding information, we are elaborating. The second simplest one is the composition-decomposition. If we are elaborating, we are decomposing things into smaller and smaller blocks. If we are abstracting the composition, we are composing. It's composition versus decomposition. In object-oriented types of language, abstraction is supertypes, elaboration is subtypes. It's a type of. The last one, which is very, very connected to architecture, is this whole, it's called elaboration and realization. Idealization and realization. So idealization goes up, the further we go up, the more ideal the information is. The further we go down, the more real the information gets. This is where you get contextual, conceptual, logical, physical, operational. That's where those things come from. So all of these 4 ways are all ways of doing abstraction and elaboration. But architecture tends to always be going up. We compose things into bigger things. We think of bigger types. We think of conceptual and logical and conceptual. We kind of go up the thing. Whereas engineering tends to be about decomposition, adding more detail, creating more types from supertype, etc. Architecture tends to be finished when there's nothing more to remove, as I said before, nothing more to add. The most important tool for an architect is his eraser. I would also say his mind. This actually comes from there's an architect called Francis Lloyd Wright, I think. In my book there's a whole load of quotes from him which are fantastic. You read his quotes, he's talking about building architecture, but you read the quotes, they apply to any type of architecture. You can apply his quotes to solution architecture. So we're about erasing things and thinking about things. These are about drawing things, more and more things, and building things with your hands. In terms of work, architect tends to be more about thinking, engineering is more about doing. Architects consider what is yet to come. We have to plan. Well, what's happening? Like someone said earlier on about planning for change, later change. So we think about what is yet to come, whereas engineering thinks what has been. Oh, we're going to build it this way because that bridge was built that way, and that's a really great engineering way of building the bridge. The best friend of an architect is an engineer. The best friend of an engineer is an architect. a lot of the time when you talk about any of these things, you get into arguments because people think it's hierarchical. Architects are more important than engineers. They're not. They just do different jobs at different times. That's all. Architect tends to be driven by the client. So the client says, the architect says, what do you want from the client? And the engineer says, what do you want from the architect? They tend to view breadth and big picture, one of the things that you wrote down, whereas engineering is more about depth and big detail. Architecture wins long term. Architecture is all about long term wins. People, it drives me mad when people employ architects and they go, right, we need to concentrate on some quick wins. So don't talk to me, don't talk to the engineers. Architecture is about long term wins. It's setting the fundamentals in place. Whereas engineering is much more about short term. Maybe you can think of that, those Scrabble letters I was having. This is more about long term, thinking of the big picture that's going to change over time. This is more about short term, let's do engineering, engineering, engineering. But engineering without the context of architecture is prone to lots of problems. Can you cost justify architecture? No. Maybe you can, but basically you can't. One of the good things that one says is you can't cost justify architecture. I don't think you can, because it's all about the long term. It's all about, one of the things in books and things, is that architecture a bit like snake oil salesman to a manager. One of my slides says, to a manager, how can a manager discern between a snake oil salesman and a charlatan and an architect? It's very difficult, because they both kind of talk in the same way. Oh no, this is fantastic, do this, really important, if you don't do this, you're going to die. And when I see the benefit, next year. The true value of architecture is intangible, which is why you can't cost justify it. Quality, how do you measure quality? How do you measure scalability? How do you measure the fact that we put in place an architecture that's going to allow us to do whatever we want to do going forward? Whereas engineering is much more tangible. It's literally bolts and nuts and pieces of software and whatever. Architects, when they are wrong, they love it. I love it when someone tells me I'm wrong, because it means I can change things and improve things, and the next time I talk about something, it's improved. I absolutely love it. Engineers hate it, because when engineers get things wrong, people die, potentially. Serious things happen when engineers get things wrong, so they really don't like to be wrong, which is fine. Change, they're all about, architects tend to be more about creativity, which is creating new things, thinking off the wall and all the rest of it. Engineers tend to be more innovation, so I distinguish the two in, that's more what's the words? I'll come back to it, I'll remember the words. Architecture is more about the lines, engineering is more about the boxes. So if you draw a picture with boxes and lines, the architecture is the lines, not boxes. The engineering is boxes. It's not a hard line.
Are there the relations between the plots?
Yes,
the relationships. Talking about the objects and the relationships.
Yeah, it's the networks.
Yeah. One of my sayings is the values in the lines, not boxes. Think about like an architect. So,
yeah. On the uncertainty, do you think there's something about risk in there as well? Is it uncertainty and risk?
Well, is it risk? Well, risk is assessed uncertainty. Risk you know about.
Yeah.
Uncertainty you just don't know about. It's the unknown, isn't it?
The uncertainty
So the
implies
relationship between risk, uncertainty, and certainty, isn't it? Because you're trying to make uncertainty certain through an assessment of risk.
you can't make uncertainty certain. It implies that you worry about things you don't know.
Yeah.
So the architect has to design something so that it will survive unknown events. Whereas
so the category
an engineer
flexibility
tends not to do that. They tend to design for risk.
Yeah.
So if the category is risk, would we say that engineers can be more clear about risk the
quantified.
Is it tolerances or things like that?
There's a
isn't
high
it?
probability that they're going to reduce the risk a lot more than an architect.
Yeah, because I guess they think in terms of tolerances. I don't know if that's relevant or not.
They're working on the.
It's like they can put a figure on it.
They're working on. They're working on
statistic on it. Can't
They're
they?
working on the unknowns, whereas the architect is working on the unknown unknowns.
Yeah. Yeah, the sort of know.
It's the known unknowns.
There's the known knowns. There's the unknowns that you know about. And there's unknown unknowns. You don't even know you don't know it.
And that's what the architect. Yeah, and that's what the
That's
architect.
what architects got to deal with.
You see, that Donald Rumsfeld, when he said that, that was so important,
It
what
was.
he said.
It was.
And what did the stupid people on the news go? Oh, he said the silly thing, the knowns and knowns and knowns. It's like, no, that's really,
Yeah.
really important.
It is. It is. I agree. I quote it myself exactly because of the validity of that statement. It's very powerful statement.
It was.
Yeah, I thought it was all.
I think that's quite interesting because then it starts bringing in like a third dimension where we see sort of outside in, inside out, and outside out. Because when you're now starting to think about the experience you're trying to provide to a person, a user, that you need to think about, okay, where does that actually begin? And so it might be thinking beyond the normal constraints of an enterprise, wherever that may be.
Well, enterprise is creative.
Yeah.
It's a human endeavour. You make enterprise, you create things, you create poetry or whatever it is. Enterprise is like, it's in the same bucket, but it's a different form of creativity. It's creativity, and that's what the architect's got to deal with because you're trying to architect that creativity. So you understand it and then make it so. And I guess that's where the engineering comes in.
I know when I look at risk, I think about business continuity. So it's not just about there's a fire, there's a flood, there's a war, there's an asteroid, there's a 747 laying on the building. It's also the other things about, what happens if I lose this service because of a business reason or a security reason or whatever. Those are the kind of risks that I'm thinking about what we're trying to actually cover. And if there's a business that doesn't cover that, we're going to accept that.
It's the other thing. I can always quote the classic examples like that BlackBerry and Apple. You're doing nothing wrong. It ain't broken, it doesn't mean fix it. But actually, in context, you're just not aware that somebody's coming in with a design what the purpose of handheld devices, mobiles, and so on.
Yes.
Look at a completely different lens. That's your risk. You're finished, basically.
Yes.
And yet, there's nothing to suggest there's anything wrong. So, how can architecture capture? But it's not
Difficult to quantify risk, and even when you
don't know it's even there.
even when you identify it, to get other people to believe it's a risk
Yeah.
is difficult because you can't quantify it. It all sounds airy fairy and charlatan.
It does.
I have a feeling that there's something that an engineer does which involves taking things, components that already exist and are proven, and putting them together in well-known ways. So if you're building a helicopter, for example, the job of the engineer is to take components that are well understood and integrate them in ways that the engineer knows will deliver the outcomes that the architect has specified. Whereas the architect is doing something similar, but at a much more conceptual kind of level.
Yeah. They're both doing reuse, aren't they? But the architect's more logical, conceptual. Because the architect of a building, the patterns they're using is arches and plinths and things like that in buildings. That's kind of reusing those patterns.
Come back to this point about networks. So if you're an architect, the thing you're designing, the building, is the corridors and doors and rooms, which is the space network that people are going to use to get to things. Then you've got to say there's another network which is the electrical network, which is going to connect to all the bits. And there's another one which is the drainage network, which is going to take all the waste away and all the rubbish away. And so, and if you think in the different layers or types of networks, all of which have to come together, so that when a person is sitting in the building at their desk, they're connected to the space around them, the lighting, the plumbing, the waste, the knowledge, the information, all of the networks they need in order to do the job. The architect's job is to do that thinking, which is very conceptual. And then the engineer comes along and says, I'm the space architect, I'm the space engineer, I know how
We're back to this, aren't we?
I think
it goes back to this point about networks. So
I think there's another
I
dimension as
just
well,
don't see
because
it being recognised.
yeah, I'm just wondering
Networks
if
is in the lines, not the boxes. Networks is all about the lines. The relationship between a desk, the relationship between the desk and the toilet, and the light switch, and the water. That's all the relationships.
I think what goes beyond the line side.
But what I'm
because
saying, I think it's more fundamental than we're. This is the sort of. I think so in the last couple of years, there's been a huge amount of literature and writing on networks and complexity coming out of Santa Fe Institute and things like that. You've got Jeffrey West's book on Scale, which is all about networks. You've got Barry Bass's book, which is all about networks. There's been a huge amount of development of thinking about the power of networks. You've got Niall Ferguson just written that book, The Square and the Tower, about networks. I think as architects, we need to catch up, look at that thinking and say,
So
what does that mean for
so
us?
I agree with that thinking, because with the lines and the boxes, so traditionally that used to be things like how do we put it all together, how do we integrate and create something, where I think now what we've seen definitely from influence within the industry in sort of the digital and cognitive era coming together is that now it's, as well as doing the lines, you also need to understand the outside of the boxes. So you've got interchangeable boxes. So as you're looking at the reuse of patterns and blueprints, that those boxes can move and they become interchangeable. So I think with the box side, the architect has to understand the box and the dimensions of the box, but what's actually inside the box, sort of the engineers still living inside the box, doing that level of decomposition.
Yeah, but what you can do is with boxes, you can go down the hierarchy, so you can do the subtypes and that, you can define that, and you choose how you can polymorph and substitute it, so like a managed employee, for example, and the dimensions of that are contained, and the way that you do the sort of the houses is the relations, because really the specialised boxes is a relation. It's a specific kind of relation, so you could draw it as a relation. Manager, employee, it's just another relation. Yeah. So I think that's the way you try and square the circle, is you could have your hazards and your isers, and you can,
or your eyes and your e's.
Your eyes, or whatever it is, whatever
that level
whatever relations you want to put on your graphs or on your boxes.
Are you saying then that the engineer is more interested in these ISA-type relationships?
Well, my experience has been that engineers think that ISAs is a very constrained way of thinking. When they think of composition and decomposition, architects think, well, how can you break it down according to subtypes? So you have a box, and then you say, right, this is a new employee self-service system we're trying to build here. What sort of employees have we got? Oh, we have managers, or we'll have executives, or we'll have casual workers. And you think in that sort of thing, whereas an engineer will not think in terms of ISAs or hazards, so they'll think in perhaps in terms of what are the parts of the employee self-services. To them, that's a way of decomposing the employee self-service. Whereas an architect may think in terms of size. And sometimes I think they're both, to me, the ISA comes out of software engineering, so that's the word engineering in it. But there is, I'm noticing, when I've seen something like that, and they've said, oh, that's not an ISA, you can't do that. An engineer will say to me, well, I'm trying to decompose it, I've got to understand its parts. To recompose it. And that's a fundamental way of thinking that's different. That's quite a challenge.
Engineers understand by decomposition.
Yes.
Architects understand by composition. By thinking at a higher level, bringing things.
But software was taught many years ago, really in terms of functional decomposition. And what you're talking about, I think, is more data decomposition, which a lot of places never taught, and I'm not sure whether they teach them today. So I think that also.
That's right, and it's actually multifaceted. I mean, you look at development, we're off topic here, but you look at programming languages, you can see how
you've worked with different
methods like
LSTMs.
Yes, it is.
Data modelling it.
Yeah, exactly.
I remember saying it's MSADM when you had the data models and all that kind of stuff. But I think that's the way, it's just that this congruency in the way of thinking, I think that's.
I think the architect has to be able to do both decomposition and I think you have to go in both directions, because I think what happens is the business says, I want this, and they give you something visionary. I want to be the Uber of Right?
Sure.
And then you're decomposing the Y. So if you want that, then you must have these parts. So you've now got a part of decomposition. And then when you get down to the bottom of the part of, you're back at the sort of use case level. You basically recompose back up the ISA. You say, well, that part is a type of and it's a type of electricity, let's say, which therefore is part of the electrical network. And this part here is a part of a drainage, and that's part of a drainage network. And then you've got your engineering domains. Then you can go in and get your engineers, and the engineers will do the made of network. The made of decomposition, which says, this bit, and in software, this bit's going to be SAP, that bit's going to be Microsoft, that bit's going to be, and they're doing a made of kind of structure. And so you've got three structures. You've got part of, type of, and made of. And I think the engineer, the how is made of, the architect's doing the part of, and the interface between them, which is what you've got on your list. Is that what?
But it's also interesting.
This is that type of.
We need to. I have to put it in because we're running out of time.
Okay.
Unfortunately, but there's a slide. There's a slide on our website or part of the stuff which explains all this abstraction, elaboration, and things like that. But just to finish off this thing here, unfortunately, we don't. We could be here. I prefer if this section was like 3 hours long, and that we started late because we didn't have this and that, etc. Anyway, so. There's something also in our frameworks called the Pragmatic Architect's Creed. There's 3 pillars of statements: communication, integrity, and understanding. And then there are things that that architects are and behaviours of architects. You can go to pf.com/creed, and there's lots of words written about all of these things. So I just really, not to go through this, but I just wanted to point that out. I'd like to see when people get recruited, we pay companies pay more attention to who they're recruiting. Because when I've been recruited as an architect, I don't think in all of the interviews I've been to and of all of the jobs I've gone for, anyone's really asked me any questions to do with architecture to find out if I'm an architect. This is what I'm saying. People employ people as architects. They have no idea whether they're an architect. They're probably not. So that's a useful thing. The other thing, I'm going to do a survey. Anyone change their mind about what they thought they were and what they think they are now? This works better when there's 50 people in the room, obviously. To let you know, we have PF training is free. It's self-study training, but you can get trained and certified in our frameworks for free. Just go to pf.com/free. We have various books. There's another 4 or 5 books that's on that list. They're either available as physical books or Kindle books or free. If you just go to pf.com/books, there's a link at the top to go to ISSU, I-S-S-U-U, so you can read everything for free on that. So you get free training, get trained and learn it all for free, read books online for free. Or pragmaticea.com or pf.com, goes to the same place.
Are you the guru behind all this?
Yeah. All this was created by me working at various companies over about an 8-year period from, 6-year period from 2002 to 2008, failing at enterprise architecture. And the reason I failed was not necessarily because I didn't know what I was doing, it was because the people I was working for didn't know what I was supposed to be doing. So they'd get me doing solution architecture jobs, so I have to explain that. Here it's not this big essay, it's different. So over that period I created a lot of stuff to stop people failing in the same way. That's why I say it's 20% of the fundamentals. Half of it is do these things, because if you don't do these things, you've got a 90% chance of failing. And the other one is, if you do these things that we're telling you not to do, you've probably got a 90% chance of failing. Something I want to try to start is this Global Association of Enterprise Architects and Engineers. It's to try to build a profession. Various people have tried to build professions in the past, but really all they want to do is they want to own enterprise architecture. So this is not enterprise architecture focused, this is enterprise focused, and the two fundamental disciplines are architecture and engineering. We need a profession. We need to stop people building houses, or we need people to stop architects architecting houses when they're engineers and they haven't had any architecture training. They don't even know what architecture is, and yet they're architecting houses. We don't let that happen in the physical world. Well, enterprises are very, very, very important. People's lives depend on them. Their work depends on them. We have to start getting serious about this stuff. So if you just go there, you can send an email saying, I'm interested. Basically, we're looking for, I'm looking for people to run it. I'm looking for people to be a treasurer and be the managing director. And so I don't really want to own it, but I'm trying to create an environment. Because I've spent 30, 40 years working in a system whereby a lot of the time you feel depressed. Because you're working on a project that you know it's a crap project. Everyone on the project knows it's going to fail because it doesn't integrate with that. They weren't allowed to buy it. Everyone moans down the pub on a Friday night and all the rest of it. And it's just so depressing, especially when you're working on a project for 6 months that you know is rubbish, and they finally can it, and then it's like 6 months of my life, my passion, has just been wiped away. Or wasted 6 months of my life. So this is not only to create a profession to help enterprises, but to create a profession, not a union, but more of a profession for people working in the transformation domain to start taking ownership of their domain and saying, hang on a minute, you're forcing us to do the wrong thing in the wrong way, at the wrong time with the wrong thing, and then when it goes wrong, you blame us. We're not going to take that anymore. We're professional people, we know what we're doing, and we need a profession. So don't have all of that. And I'll just leave you these links. All of the stuff that you've seen today, I'll put this up again in a minute, but all the stuff you've seen today is in the frameworks. If you go to, just go to pf.com, just go to pf.com. If you click frameworks, that will then load up a page of every single image in both Poet and PF. And when you click on one of those images, so for example, we've been looking today at architecture and engineering. So that slide, if I click on that slide, then you get the slide, but then you get the words from the book associated with that slide. So everything you've seen today, like this, including this thing that we just looked at last, you can go and look at it. That's another way of consuming content for free as well. So we've kind of finished.
Brilliant. Well,
any last questions from anybody?
thank you, Kevin. Lunch is being laid out, so help yourselves.
Thank you. Thank you.